So when two cations get to the cathode, the one that accepts electrons more easily or readily will tend to be discharged at the cathode, as against the other that doesn't accept electrons readily. So when we consider sodium ion, for example, and hydrogen ion, the hydrogen ion tends to accept electrons easily or readily as compared to sodium ion. So for that reason, hydrogen ion will be discharged in preference to sodium ion. And again, it is far lower than sodium ion in the electrochemical series. So this is why hydrogen ion will be discharged at the cathode in preference to sodium ion. So it has more tendency to receive or accept electrons than sodium ion. In the same way, when we talk about anions, when two anions get to the anode, there at the anode they compete for discharge. So the anion that is lower in the series will be discharged in preference to the one that is higher in the series. So that is actually the general rule, that ions that are lower in the electrochemical series are actually being discharged. They tend to be discharged in preference to ions that are higher in the electrochemical series. So we have seen what position can do to ions when it comes to discharge. And we have taken a good example of electrolysis of sodium chloride. And we've seen that between sodium and hydrogen, hydrogen will be discharged. And between the chloride ion and the hydroxy ion will be discharged. Now let's take a look at electrolysis of acidified water. This is an apparatus, as we can see displayed on the screen, called the Hofmann voltameter. The Hofmann voltameter is an apparatus specifically used for carrying out the experiment called, or the procedure called, electrolysis of acidified water. It can also be called electrolysis of tetraoxosulfate 6 acid. That's aqueous tetraoxosulfate 6. When we say aqueous, it means it has been dissolved in water, of course. So, but commonly it is called electrolysis of acidified water. Now, the Hofmann voltameter has 3 arms, but the middle one is a point through which the acidified water is introduced into the device, and then the whole system is connected to a source of electricity, either a DC source or an AC source. Now, what really happens when electricity goes into that apparatus? The whole system will be considered to be electrified, and let's observe quickly what happens. This is a case where we have acid and water. So let's put down this again. Let's put down this carefully again. So here we have H2SO4 dissolved in water. This is not a case of sodium chloride in water again, but it's H2SO4 in water. Now when electricity goes through that system, this acid is going to split into hydrogen ion and the sulfate 6 ion, SO4 2-. Water also splits into hydrogen ion and hydroxyl ion or hydroxide ion. So we can see that here we have 4 ions in total, but 2 of these ions are of the same kind. That is the hydrogen ions. So hydrogen is hydrogen, whether it is from acid or from water. So we have hydrogen ion from acid, hydrogen ion from water. Both of them migrate to the cathode. And as they get to the cathode, they are all hydrogen. They are not competing with anybody. This is not a case of hydrogen and magnesium or hydrogen and sodium competing for discharge. This is all hydrogen. So they will be discharged at the cathode. And we have that hydrogen gains electron. It is proton rich. So it gains electron to become single hydrogen atom, and then the single hydrogen atoms combine with other atoms to give hydrogen molecule. This is a stable form of hydrogen. But in the case of the anions, SO4 2- and OH, migrates to the anode. As they get to the anode, they tend to compete for discharge. So like we've seen before, the distance between SO42 minus and OH is far, as you can see. Still here looking at the gap between SO42 minus and OH minus. Their gap is very far, so that tells us that OH minus will be discharged in preference to SO4, because SO4 is higher in the series. It is more electronegative, as a matter of fact, compared to OH minus. So we have it that the OH minus will be discharged in preference to SO4 2 minus. So it will be discharged, and at the anode it loses electron to become single hydroxyl species, and the single hydroxyl combines with other hydroxyl to give us water, H2O, and oxygen atom. The oxygen atom further combines with other oxygen atoms to now give us oxygen gas. So we can see that at the anode, oxygen is liberated, and at the cathode, hydrogen is liberated. That is why we can see the device having this type of setup. And we can see at the anode, oxygen is liberated at the anode, and at the cathode, hydrogen is liberated. Usually, the volume of hydrogen liberated is always 2 times what oxygen is. So if the volume of oxygen liberated at the anode is for example 15 cm cube, then the quantity of hydrogen liberated will be 30 cm cube. So take that into consideration. Consider that very well and memorize that. So we can see that the volume of hydrogen is always 2 times the volume of oxygen in electrolysis of acidified water. So it is very important that we take note of that. Now, when we talk about the increasing preference for discharge, it is worthy to note here that fluorine is the most electronegative of these anions, followed by SO42 minus, followed by NO3 minus, chloride minus, bromide, iodide, and then last is OH minus. So students, it is important that you shouldn't confuse it thinking fluorine, because the diagram went that way. Do not get confused thinking that fluorine is at the bottom, that is its least, while hydroxide is the most electronegative. Please don't get it confused. Fluorine is the most electronegative there, followed by SO42 minus, NO3 minus, chloride minus, bromide minus, iodide minus. OH is the least, and that is why this arrow is showing us increasing preference for discharge. Increasing tells us that fluorine is least to be discharged, but OH is most easiest, let's use the word, to be discharged. So we can see that is what it tells us, because it is least in that family, just like we have gold here to be the last in the family of the cations. So this is actually how position of the ions in the electrochemical series can affect the discharge of ions. And we have just seen the electrolysis of acidified water and the quantity of hydrogen and oxygen that is being produced at the amps. So with that, let us proceed. The next we are looking at is the concentration. That is the next condition we want to consider now. We have seen the position of ions in the electrochemical series. So the next we are going to look at is the concentration of ions in solution.